The James Webb Space Telescope has detected light beyond the Dark Ages, a period of time that began just after the Big Bang and lasted about 1 billion years. During this time, the universe was supposedly filled with dense clouds of neutral hydrogen gas that blocked out all light, making direct observations of early galaxies long considered nearly impossible. But now, scientists have found that strange sources of light are coming from these dark ages, and we must seriously wonder if we have misunderstood the universe so far. Using the James Webb Space Telescope, or JWST for short, the mystery of the Dark Ages has now been solved. The telescope's discoveries show that there was indeed light during the supposed Dark Ages. Webb observed Lyman alpha emissions, which are produced by the interaction of ultraviolet light from young hot stars with surrounding hydrogen gas. Surprisingly, this light reaches us, so it was somehow able to penetrate the dense hydrogen clouds of the Dark Ages. Researchers speculate that this was most likely made possible by the formation of bubbles and channels of ionized hydrogen. The ionized hydrogen came from the first stars and galaxies, which created bubbles and channels, and thus gaps in the neutral hydrogen gas, and it was through these gaps that the Lyman alpha emissions escaped. The first discovery of Lyman alpha emissions from this epoch was some time ago, even before the launch of the new space telescope. Researchers were able to receive and study these faint signals from a largely unexplored period. The Webb telescope is now showing us yet another facet of this discovery, and it has far better capabilities to detect and analyze the Lyman alpha rays. So far, the overall picture suggests that the first galaxies and stars were formed much earlier and on a larger scale than previously thought. Since its launch in 2022, the JWST has shown us a series of galaxies that were already very advanced and bright during the Dark Ages. The very fact that we can see these galaxies shows that there was even more light in the Dark Ages than previously thought, and that the Lyman alpha emissions were not the only waves that penetrated the darkness of space. So far, the discovered galaxies show all signs of an extreme star formation rate, and they are unusually large. The evidence of intense star formation alone paints a very different picture of the early age of the universe. If there were more stars in the past, then the universe was also illuminated and permeable to light earlier. Based on the current situation, scientists must also come to terms with the idea that the Dark Ages never existed. One of the most significant discoveries of the JWST are two high redshift galaxies that are so old that they existed long before the Dark Ages. The age of these galaxies is so extreme that, strictly speaking, they must have existed even before the Big Bang. This shows that something is wrong with our previous data. These galaxies have an extremely large number of properties that do not match the previous models of the origin of the universe. Another example that is currently giving scientists a headache is the discovery of a supermassive black hole at the center of one of these galaxies, which existed only 400 million years after the Big Bang. Such observations completely challenge the current understanding of the cosmological time scale and our old theories of galaxy formation. The real reason behind Lyman alpha radiation is still uncertain, but it is known that Lyman alpha galaxies play a crucial role in the study of early galaxy formation and evolution. Now, we just need to find out what exactly these emissions are telling us. Lyman alpha emissions are produced by the transition of electrons in the hydrogen atom and are normally found in the ultraviolet spectrum. From our point of view, however, the emissions are increasingly redshifted because the universe is expanding, and the light of the waves changes optically for us. This effect gives us the good fortune of being able to better capture and study the emissions. The JWST is virtually predestined to capture waves in the red light spectrum. Lyman alpha emissions, or LA for short, are like a silent beacon for scientists from the times that we have long considered to be the earliest phases of the universe. They enable astronomers to identify and study processes in galaxies that took place just a few 100 million years after the Big Bang. This should actually be the time period in which the first structures in the universe were formed, and LAs would therefore be important messengers of this time. However, emissions can also play an important role in changing our view of the universe. This is because we no longer know whether the idea of the Big Bang is really true. All observations are important new indications of a worldview that is different. Scientists wanted to use LAS to clarify the processes of the reionization epoch. Until now, the idea was as follows: after the Big Bang, the universe went through the so-called Dark Ages, a period in which there was no light because there were no stars or galaxies that could produce it. On top of that, the universe was still a very dense soup where light rays could not have passed through. The point at which the universe became bright and permeable to light is what scientists call reionization. LAS must have played a key role in this. But what if neither a dark age nor reionization really existed? Then researchers have misinterpreted the LAS so far. Thanks to the latest discoveries from the Webb telescope, the picture is becoming clearer now. By studying LAS, scientists can better understand what was going on in the galaxies Webb shows us. LAS provide reliable information about how many new young stars have formed in galaxies and how the intergalactic medium has behaved during this epoch. By studying LAS intensively with the latest telescopes, scientists will continue to gain more information about star formation rates in early galaxies, and this data will help us piece together the puzzle. Eventually, we will know if these galaxies are really baby galaxies in a young universe or if these galaxies formed in a completely different way and are much older. The images that the JWST has provided us with so far show astonishingly starry and bright galaxies. If we want to understand what happened in these galaxies, we need to use every available source of information. Another high-power telescope, the Vera Rubin Observatory, will soon be launched to give us even more clarity. All we know at the moment is that the strength of the Lyman alpha emission is often an important indicator of the amount of new star formation. The jets are also produced in star-forming regions that are much younger. By measuring and analyzing these emissions, scientists can quantify star formation activity in early galaxies and thus draw conclusions about the processes that led to the formation and evolution of these galaxies. Webb discovers more and more LA galaxies. What this telescope is accomplishing is truly mind-boggling. The James Webb Space Telescope is looking farther and farther back than any other telescope before it, and it has revealed impressive examples of Lyman alpha emitters that are now so important to research. One of the most notable of these discoveries is the galaxy GN-Z11, originally identified by the Hubble Space Telescope and later confirmed by the JWST. With Hubble's measurement data, researchers still thought it was a mistake because GN-Z11 existed around 400 million years after the Big Bang. This age was already unusual in Hubble's time, but it was thought that perhaps this galaxy was a measurement error or a strange outlier. Now, thanks to James Webb, we know that it's real and that Hubble did not make a mistake. The spectrometers of the JWST show strong Lyman alpha emissions in this galaxy, which again points to intensive star formation in this galaxy. GN-Z11 has thus heralded the revolution in scientific understanding of the rate at which galaxies can form in the earliest phases of the universe. Another important example is MAX 0647 JD, a galaxy discovered in an early galaxy cluster. This galaxy is extremely faint and is in a very early phase of the universe. Nevertheless, the JWST observations show that MAX 0647 JD has strong Lyman alpha emissions and is thus producing a large number of new stars. This galaxy shows unusual activity for an actually faint and presumably small galaxy. Finally, we have the galaxy EGS-8P7 in this list. It lies around 13.2 billion light-years away and also shows surprisingly strong Lyman alpha emissions. These emissions suggest that EGS-8P7 was able to create bubbles of ionized hydrogen around itself that allowed the LAS to escape. There is still the question of whether the idea of reionization was correct because the JWST shows us several galaxies from this theoretical epoch that are much too bright. So far, however, we have not found any signs of a darkness that has obscured everything. The strangest black hole in a galaxy. Let's take another closer look at the galaxy GN-Z11, which existed about 400 million years after the Big Bang. A supermassive black hole has been identified at its center. This discovery once again raises many questions about the formation of such massive objects in the earliest epoch of the universe. The presence of such a large black hole at such an early stage contradicts previous theories which assume that supermassive black holes are formed by the collapse of massive stars or by the merging of smaller black holes. These processes take billions of years, and so this black hole is also scientifically impossible. What does this discovery now tell us about the old theories and their veracity? We have to consider that alternative mechanisms for the rapid formation and growth of black holes also exist. One hypothesis is that these black holes gained mass rapidly through direct accretion of gas in material-rich regions of the early universe. Other hypotheses suggest that previously unknown forms of exotic matter or energy could be responsible for the rapid growth of the universe. It's astonishing that so few scientists are currently able to officially dispense with the idea that the Big Bang possibly did not exist or that it took place much earlier. Conservative science is currently fully committed to reconciling the old worldview with the new discoveries by finding explanations for a kind of turbo formation. The Lyman alpha emitters are supposed to help with this. But what evidence is there that the universe is possibly much older? The enormous black hole in the galaxy GN-Z11 indicates that the dynamics and development of the galaxies discovered by Webb were very similar to today's galaxies. Other discoveries by Webb also show structures that indicate a universe that is well advanced in its evolution, and this just a few 100,000 years after the point in time at which we assume the Big Bang occurred. The scientific race is currently in full swing. Some want to prove that the idea of the Big Bang, the Dark Ages, and expansion was correct after all, and others are doing everything they can to use Webb's findings to confirm alternative ideas. Subscribe to the channel now and look forward to many new video highlights.